Thank you everybody for joining my talk. It's about evaluating the agentic platform, building evaluation infra for agents across the entire SDLC. My name's Glyn Darkin. I work for a company called Clearroute. If you were at the conference yesterday, you would have probably seen Clearroute around a fair bit. We're a platform engineering consultancy. And over the last sort of year, we've been leaning quite heavily into AI engineering to understand what our customers and clients will be looking for to build. And therefore, from a platform perspective, what are the types of capabilities we need to build and engineer? How would we run AI agents on platforms, that kind of stuff. What I'm going to be presenting today is all on GitHub. So you can see my handle there. You can find it on GitHub. If you want to contact me, ask questions or anything, please hit me up on Twitter or LinkedIn. Be more than happy to discuss what we talk about today, or anything else for that for matter. Okay, so I've done a previous talk around agents in the SDLC and how to eval them, right? So, we're now in a world where we're going to have multiple agents in a full software development lifecycle. That's kind of the target that we're building towards. So how do you test that as a system is really what we're kind of talking about and going to talk about today. One of the things that's kind of a fact is the models that you use today won't be the models you'll use tomorrow. This is really, really important from a systems building perspective as we build our platforms. Even in the time of me preparing this talk, the models have changed. Fable appeared and Fable disappeared. And that impacts our systems that we're building if we're using these models, right? We're seeing a massive increase in the capability of the Chinese models, the open source models. I think right now we are, people like myself are still heavily using subscription-based services like Claude and Anthropic's subscriptions, but we're now starting to see people shift from subscriptions to token-based billing. We're seeing that with Copilot as an example, and even Anthropic's own, if you go for their enterprise system, you pay for every token, right? So what you use as a developer coding at home, when you're only paying $100 for a subscription, could be thousands of pounds in tokens, thousands of dollars in tokens. So then it raises the question, well, are those the models you should be using? NVIDIA published a paper a while ago where they believe small language models are the future of agentic systems. For example, I have an agent, which I'll present later on, that does release notes. Does the model that we're using need to know everything about Shakespeare? Right? Probably not. And so as we move through the phase of the life cycle of these technologies and we start to embed these in our agents, we're going to probably start to use smaller, cheaper models for more bespoke solutions. And so the question then comes in, how do we test those, right? So if we build an agent using one of the more expensive, more capable models, and as we mature our agent skills, we then want to reduce the model that we're using to use a cheaper model. We need to be able to test that, okay? Not only test it by itself, but test it in its full life cycle. I talked about Fable just disappearing the other day. What's interesting again in the last week is we now have an open source model, GLM 5.2, that's just been released. So the system that I built at the moment today uses Haiku, so nice and cheap to run and quite intelligent. If I replaced that Haiku with GLM, how do I know my system is still going to perform the same way? They're the kind of exam questions we're going to be getting asked, right? And this really, again, because it's PlatformCon, the platform perspective is what are the capabilities that we need to build into the platform so that we can swap these models out. So the North Star now is, what is the name for the North Star is being sort of termed as a dark factory. So the idea of a one-shot system where you can drop an idea or a requirement into the factory and it will plan, design, build, validate, and deploy that feature. We're starting to see good examples of that. So I think the dark factory concept was coined by StrongDM. They're a security company. They have an onboarding tool, and they basically built an entire digital twin and were able to run full test life cycles on it all without all automated through AI. And they could build and run this system over and over again. And that kind of coined the term of the dark factory. So the idea of like building change and running your system and testing it. back over in January, Steve Yogi built Gastown, a multi-agent platform where, again, you can drop a requirement in and all of these agents will work together and deliver that requirement. Quite a complex system, but quite an interesting read. Stripe have built Minions, their one-shot system. So, they've obviously quite a mature engineering environment. And now we're starting to see sort of terminology built around this. So harness engineering is kind of a new term that's being coined around this. So I'll share these slides, these links. So ThoughtWorks published a blog post now and calling this harness engineering. So still, what we're seeing is, this is a kind of almost like the next generation of platforms that we will have to build. How do we test those? How do we optimize them? So if we take a route to live, full sort of software development life cycle, this is a capability map of kind of like all of the features that you would have in a sort of traditional software development life cycle. The green line through the middle is kind of our critical path: discovery, initial setup, system design. You go into development, reviewing, merging code, you're building your solution, you're deploying it, you're testing it, you're then doing rollout of that solution, you then want to optimize features, and you need to maintain it over time, right? So these are the kind of categories. Below the line are a lot of the deterministic automations that we would have, or parts of the system that we would want to build. Above the line are ideas where are kind of hypotheses where we could use agentic systems or LLMs to create automations that add value to the system, right? So a lot of these are ideas. I think this is still all evolving. But if we take, I've kind of highlighted here in purple, a set of these capabilities, can I build that into a software development lifecycle? So an AI coding agent, take a security agent, security review, a PR agent, eval testing. So we'll come on to that later on. A little release notes agent, contract testing agent, and then a root cause analysis agent. So take those as a part of my spine and my software delivery lifecycle. I think with the advent of we're starting to see with a lot of our customers a huge amount of security vulnerabilities coming through into the platform teams. So a huge sort of influx coming from a lot of the vendors that have Mythos and have been doing a lot of analysis of their own systems. They're now identifying security vulnerabilities that are coming through that we're having to update a lot on a lot of our customer sites. So I think it's really important that a security agent and your security, your sort of DevSecOps lifecycle becomes a first-class tenant, right? That's why I have a code review agent and a security review agent as two separate things. So what I've done is I've built a sort of simple dark factory on GitHub. I've taken 6 agents, so that code review agent, so coding agent, code review agent, security review, release notes, contract test, and root cause analysis. And so that is my dark factory, the idea of taking an idea, I put it in as an issue, and it goes all the way through and deploys it. So the SDLC, so what does that sort of build lifecycle look like for this? So I've got effectively 3 kind of workflows: issue to PR. So create an issue on the platform. If I tag that issue for my agents to pick it up, my agent, so this is kind of like the human steps, then my agent will create a branch, review the issue, plan it out, do a code fix, raise a PR. So that's kind of like the PR and raise a PR event. I then have a PR to main. So I then have an agent that will, on a PR, on that PR ready event, it will then do a code review. It will do a security review. They're the 2 sort of agentic systems. And then it will do some of our typical automation, right? So run unit tests. It will deploy the preview to Vercel. It will run some smoke tests. And then if they all are successful, it will automatically merge and push that PR to main. So there's no human in the loop here. So it's a true dark factory. Once it pushes to main, it will deploy the preview again, do another smoke test, do a contract test. It will generate release notes, and it will promote that to production. And then it spins up an RCA agent, so root cause analysis. So it's looking for errors in the log file. So if there's any traffic gets hit and there are any errors generated, it can then either raise an issue raise a fix, and then the loop starts again, right? So this is quite an idealized workflow, but it's a good way of building something so we can start to understand the complexity of like, well, how do I test this as a system? What are the tools and capabilities I need in the platform to do that? So the anatomy of an agent, just to remind ourselves what anatomy of an agent is. An agent is an LLM model, which is the heart of the system. It does the workflow, does the decisioning. That's wrapped in an agent framework. Typically, we can build these yourselves, but these are kind of commoditized. You have Google's ADK, you have AWS Strands, you've got LangGraph, like all the big players have one now. And if you go with any of the hypervisors, their agents are kind of catered for their platforms. They have built-in telemetry and observability, things like that. So inside your agent, you would have your prompts, you'd have your access to your tools. You may have memory so that it can build context over time. So that's your agent. That's then packaged in an environment, right? So how do you interact with your agent? Could be from the command line, like Claude Code. Could be packaged in Docker. Could be in a CI pipeline, which is what my agents will be in, or it could be a chat interface as well, right? So that's what we call the environment, and that sits on the platform. So this is the platform that we're going to be building. Um, there are lots of capabilities that you can build for your agent. So your knowledge. So this is a RAG platform where you have databases and that sort of kind of stuff for your knowledge, so it can have access to it. MCP mesh, so you've got all of your MCPs that your agents can connect to pull different things in. Your sandbox environment. So how do you run these in a secure environment? Your security controls, and then your telemetry and observability. So how do you see all of that come together? So they're all of the platform concerns. We did a presentation yesterday. Justin, one of my colleagues, did one much more about the platform and a lot of its capabilities. I would definitely recommend going back over his presentation, some of his content on that. Again, we're going to focus a bit more on the testing lifecycle of this. There's a link here to the paper, Synergizing Reasoning and Acting in Language Models. This white paper, is kind of like the foundation of where the agents came from. So that's the anatomy of an agent. When we stack that into our software development lifecycle, what are the capabilities that we need from that route to live, right? So I've done all of this in GitHub. So my runtime environment is GitHub Actions. All my secrets management is all in GitHub Secrets. I'm using OpenRouter as an LLM gateway. It's great and simple to be able to use. It gives me access to all the models, and I can control my costs very easily. So for this type of like experimentation and learning, it's a really good platform. For observability, so understanding what's going on, I'm using Arise AX. It's a SaaS platform that gives me deep telemetry into all of the agents. I will show examples of that and show how it works. They have an open source offering called Phoenix, which you can host yourself, which is pretty good. Again, it's a simple solution. I'm using it to demonstrate the capabilities that you would need to start thinking about as you build your own observability stack on your platform for these particular workloads. Okay, so as a platform, as a maintainer, as a person, I would file issues, or maybe even my agents will file issues. Platform's called Talos. We'll come into that. So I've got GitHub as my control plane with the repo, generate PRs. I've got GitHub Actions are running all of my agents inside Docker, calling out to OpenRouter. Telemetry goes to Arise. And then I've got a little app. It's a little to-do app, which is what I'm using to test and learn all of this stuff. That will get deployed onto FirstCell. Okay. So I'm going to go in and demo this factory now working. So what I'll do first is I'm actually going to create an issue and trigger the process, and then we'll go through and explore everything because it takes some time for it to run through. So I'm going to do quite a simple new issue. Title change to PlatformCon demo. Okay. Okay. So got an issue. I'm going to change the type of the application, which I'll go and show you in a minute. So I'm going to tag Talos. Please implement this change. Okay. So that's now going to go ahead and implement that change. So whilst it's doing that, I'll just explore through the total platform and how it all comes together. So we've got deployments that happen. So this is my testing. So in production, I've got my to-do app. So Talos, the best to-do app in the world. So this is the title that we want to change, and the Dart Factory is going to make that change. We've got release notes from the last release that was created. So we'll go through. So have an agent that builds those release notes. So what we'll do now is start to look at, well, what are the builds? So we saw the workflow of all of the different builds. So in GitHub Actions, I've got a set of builds that have been created. So we can now see Talos is coding up my my change now. If I go back to the issue, we can see Talos is now looking at it, which is great. Back to actions. So this is the full software development lifecycle in the sense of one GitHub Action workflow. So a PR review. So if that PR is raised, it will go through the process. It will review the PR. So it will do the code review, the security review, which we dig into. JavaScript. It will then go and deploy it, do the smoke test, generate the release notes, do a contract test. If that's all been successful, it promote it to production and then do the RCE. You can see the steps here. I've got the coding agent. So this is the coding step by itself. So if I jump in, we'll just have a quick look here. You can jump into here. So I'm using Pi as the coding agent here. Quite a simple agent, made famous because of the platform that's been used. His name escapes me right now. So you can see here that Pi's been set up. It's running. The prompt has been passed in. It's made a file change here. It's then, let me just zoom in so people can see this. Checked out, create the branch, added the file change, committed the changes and pushed them. Right. So we know that that's working, which is fantastic. So I've got some examples of some areas where it's failed as well, right? So, and this is kind of the important part of the whole process. So I'll come back to these ones later on. Let's go and see. So it's done the code change. It's now raised the PR. So the PR is doing a review. If I look at the pull request that it would have created, so here's the pull request. So link to the issue. So this is the information it's started to work through, generated by Talos, the coding agent. So it started, it's deployed, it's done a code review, it's passed it. Well, it was very simple code change. And because it's passed everything, pull request successfully merged and closed. Okay, so it's merged that into main, and now the main process is kicking off. Okay. So let's see if it's actually done the deployment. So preview's been updated. So let's go and have a look at the preview. Oh, what? PlatformCon demo. So it's updated it and deployed that to the preview, and it will go through and then promote that to production once it's gone through all of the agents. So that's a full end-to-end life cycle. Very, very simple. But now it starts begging the question, well, how do I test this as a system other than just going through and doing that, which is kind of vibes? It's like, yeah, it's cool. Sometimes it doesn't work. Sometimes the agents hallucinate because these are very simple agents that I've created. Okay, so the way that we test agents and the way that we test LLMs is a thing called evals, evaluations. So the anatomy of an eval. An eval is basically a test for an LLM, okay? Test for an agent. We give it an input, the LLM will iterate on that input, and then we grade its output. So that constitutes like almost like a test or a unit test for the system. An eval suite is a collection of those tasks with a shared goal. We have a fixed input and we have a success criteria. A trial is one attempt at running those tasks. And when it doesn't attempt, you get the full transcript, the reason transcript from the LLM. So it will go through the tool calls and everything. I'll come and show you those transcripts. And then you get an outcome at the end of that, right? And you want to pass or fail that. And to pass or fail it, you need to use a grader. I'm not going to go deep into doing into the evals and eval grading and stuff like that. There are a number of different ways of doing that. A number of different technologies. Quite often for complex stuff, you will use an LLM as a judge to check the output from these. Okay, so it can get quite expensive to run these. But you build a data set, right? So you're going to build a data set, and that data set is going to grow over time as your eval suite. Okay. There are different types of evals. So like you have the testing pyramid, we have an evals pyramid. You have a set of evals that are quick and cheap to run. So for example, the release notes, I want to keep those short. So I have everything's got to be under 300 characters. So if it's over 300 characters, we fail it. So it's a simple eval. We can have more complex ones, so directional ones that are looking at the quality of the output. So are the release notes concise? Are they correct based on the information that's been given, right? You can use, and it's a really good example, right? Because you can use a really good model like Fable to do release notes and give really, really good release notes. Or you could use a really small model to do that. And it's probably going to do just as good. But then how do you test that over time, right? So you can use a more complex LLM to test the output of the smaller LLM. And finally, you've got testing live. So as this system gets used all the time, you can actually look at different parts of the system, do A/B testing, and you can test in live as well. So that's kind of like the eval pyramid. And there are lots of eval frameworks. They're evolving very, very quickly. When I started looking at these kind of things sort of 6, 7 months ago, deep eval and prompt foo were quite big ones. Or you can build your own eval framework up yourself, right? I think that's really quite important. So we break those down, and what I've done here in this demo is I've broken them down into 2 buckets. So one is the gate. So if I change one of my agents and I deploy that change, I want to run that against a regression pack effectively, which is the gate. And if it fails that regression pack, I don't go any further, right? And that makes sure that my agent does not drift backwards, so get worse. So that is quite a fast regression pack. I then have something that runs a bit more slow, which is more around the capability. So, and this will include failures so that I know that as I improve my agents, they're going to get better and they will tick off more of these capabilities. This tends to be a lot more expensive to run. It will take longer. So this is the type of thing that would be run on a schedule rather than every time I would do a commit. And this kind of keeps track over time of like, are the agents getting better and are they improving? I think this is really quite a great way to think about that kind of the gate, the regression, and the hill we're climbing, like how we're getting better, how we're improving the system. So we've got to build this data set of evals. So to start with, for each of my agents, I built a synthetic data set. I used the LLM to generate that synthetically so I could test locally each of the agents. But there are external data sources that you can use. So Hugging Face is really, really good. You may need to pull these data sets in to provide these for your agents, right? So if you're building these yourselves, you'll have to build these into the platform. If you are building and supporting agents for your customers, you will have to be managing the data sets for them. So this is part of the platform that you'll have to do. Then the next part is once you've seeded your data sets and you kind of start the process, you want to start harvesting. You want to start harvesting a lot of your data, right? So as you start to do your SDLC runs, you want to harvest all of those runs, and then that data you will build into your regression pack. So every successful pass all the way through, that basically becomes a regression test data set for you. And if your system has failed, so if an agent has failed, then you need to introspect and look at that. Is it failing because actually, yeah, your code change was poor or something like that? Or did the agent hallucinate? So I have concrete examples which I'll go into of my agents hallucinating. And so I capture those as a data set. I then fix my agent. So I've tweaked the system prompt or I've given it more tools. And then I've got a data set so that I can protect myself from a regression. And then finally, I have a ground truth. So over time, I will have all my test suites. I will build a ground truth that I will generate, and that's like my baseline. So I'm comparing myself to my ground truth to make sure that I'm always improving and not regressing. You may have to rebuild your ground truth because a lot of your tests may become invalidated. For example, if we take the release notes agent as an example, I have a limit of 300 characters, as I said. I may decide that I want to expand my release notes now and have 450 characters. But if I've got a whole load of specifications, a whole load of evals that say over 300 is a failure, they're now not relevant anymore. So I need to rebuild my ground truth data set. So I have to manually trigger and rebuild that. So now I've got my ground truth based on the change of 450 characters. So I build this architecture into the system, right? So I've got the sources of these tasks, these evals, my seeded, which I started off with, or some external data source to get me started, then harvesting from my pipelines and harvesting from my telemetry system as well, which I'll come to, which is the Arise system that I use as an example. I'll build that into my data set. I'm currently storing those inside the Git repo, but you will see that very quickly that's going to become quite a lot of data. So as a platform concern, we will need to store this data in a secure and robust way that we can access it quickly and easy for running and update it, but you don't want to be really storing it in your source control. CI runner runs, I capture my data, and I start building this with flywheel effect of bringing all of my traces in, and now I've got the full visibility of how the system works, and I can always compare it over time. As I said, I've got the two different runs. I've got my regression run, so that's the gate. So if something fails, and I show an example of that, and then I have my capability, am I improving over time? And I will show that as well. Then yeah, that's cool. Excuse me. Let's do a demo of the evals. Okay. So at the moment, my eval data all sits inside my source code. I will flip over to there to show you. But inside Talos, I've got my agents, my code review, contract test, RCA, release notes, security review. Inside my evals, I have same structure for my data sets. I use release notes because that's quite a simple example. So here are a set of evals. I have the task. So this is a regression task, the agent that it's working for. This was pulled from version 48 because it's a real harvested data set, and it's got the rationale. The reference, so this is the release notes that it created. This was the input, which is the PR information, the PR body. And so I can now rerun my LLM against that, my agent against that data set. And so I built out this data set. Okay, all harvested from real examples. That's quite a simple data set. If we look at the code review data set, it gets quite complex. Now, when I started the code review agent, it was just working on diffs. So come back to that. So what I've got here is the task. It's a regression, it's a code review. This is tied to a pull request. This was a pass, so it passed it with its rationale. I've got the git diff, but I've also taken a snapshot of the source code at that time. I'm showing the wrong tab. Oh, am I showing the wrong tab? That's the. Can you see my VS Code? Yeah, I've got some. Okay, apologies for a moment. Okay, hopefully you can see that again. Apologies, let me start again. Okay, so in the source code, zoomed in a little bit here. Here are the agents, code review, contract test. Here are the eval data, the evals. Here are the data sets. So I'll show the release notes data set again. So I'll pick one. So here is the task definition. It's a regression test. Here is the input to that. So the release notes, PR files that were changed. This is the result it came out with, so I can compare that. So that's my input data. If I then look at a code review, which is far more complex, you'll see task harvested from a pull request, the outcome, the git diff, and then a snapshot of the source code at that point in time. So you can see very quickly my data set will grow if every single time I'm capturing I'm harvesting the source code for every single PR to go in as a data input for an eval. So you see, you're going to have to create these data sources, or you can just pull this from the Git tree every time, but then it will make your eval runs a lot slower. Okay, but you could do that. Okay, I talked about the ground truth. So every so often, I will run my full suite to generate my ground truth so I can compare. So that's stored in my repo for all my tests. Again, as I said, I would update this every so often as the capabilities of my system improve and some of my therefore eval tests become irrelevant. All right, now what I'll do is I'll show you then this all plugged together in GitHub. Change the screen this time. So hopefully you can now see GitHub. Right, so first of all, we'll look at the different jobs for the evals. So I have an evals workflow that is specific for running the full eval set. So to text change to any of the evals or the agents, and then it will run through the suite of eval tests and generate a report which gets updated to the PR for that particular eval. Let me just check. So I'm going to then. So this is a PR where and this is an example of me breaking those evals, right? So for my release notes agent, I changed the system prompt from 300 characters to 600 characters, so generate a very verbose release notes to see that the evals break. Okay, so here's a concrete example of that test. It actually failed my code review because my code review said that's a crazy idea. You shouldn't be doing that, which is great. So it failed the build, which is brilliant. But what we see here is it failed all of the eval suite. So this was the fast regression pack that it failed everything. So I now know that that's a regression. Okay, and it's also compared it to my base, right? So my ground truth 5 now have failed. So it's a total regression on the capability of that agent based on how I specified it. I've got an example of more complex a hallucination, so I'll go and show you that. So PR 71. Yeah. So adding filters onto the to-dos, so simple task that it generated. It went through, built it all. And so the coding agent, Pi, with all of the source code, was able to, and the model was available to effectively build that technical solution. When it comes to then code reviewing it, it failed it. I took then the response in the code review, gave that back to Claude and said, hey, look, this is what IQ said as a code review. This has failed. Can you please investigate it? Claude's like, that's not a failure. This is hallucinated. And the reason why it was hallucinating was it only had the Git diff. It didn't have the full source code. Okay, so this is an example of a false positive. And so this is a great example of a data set that I want to capture and bring back into my eval suite. So look, I look at my code review, it's 16. So if I look at the task, it was PR 71. It's been labeled. It was expected as a pass. It's a false positive. The grading against it. It's got the diff. So I can now rerun this test now that I've also updated it. The agent to have the full source code. I've pulled in the source code for that particular one. I can now re-execute the agent against that test and see that it's improved over time, right? Because I've added more tool calls to it. And this is a great way of capturing that drift over time. Okay, so that's everything based on that. Okay, then the last part is to show telemetry, which is really, really important part of your agents. It's been interesting when we first started building agents for our customers, we didn't really think much about telemetry because we were very much focused on can the agent solve the problem? And that's kind of like where all of the focus is and all of like the happy eureka moments are. People weren't really thinking about, well, how do we test these over time? It's only once you start playing with them and people are going, oh, it keeps on doing this and keeps on doing that and doesn't do what it's supposed to do and it's hallucinated. Do you start to go, right, I need a telemetry system for that. So here is Arise AX. So this is embedded. It's built on OTel. They have built their own sort of meta layer on top of OTel called Open Inference. And all of my agents are instrumented with this. So you could build your own, if you've got your own OTel stack already, you could use their own Open Inference meta structure on top of it. But this gives me full telemetry of every agent, every run. If I go into the code reviews, which I've got here, I can see every single one of those code review runs, how much it's costing me, and I can see at a high level the inputs and outputs. So this is the last run that we did. And you can see this is a multi-turn agent now. So Pi is iterating over the inputs, PR. If we go in, you can actually read what the system prompt is. So this is what the system prompt is telling the system to do, passes in the Git diff and the source code, and then gets the output. Okay, it's analyzing everything. And it iterates through, gets responses, and I can see everything in here. I can harvest this data, so I can then bring that back into my eval set. I can then use that as well, so I can tweak the system prompt to see if I get better outcomes, less tool calling. This kind of goes into more like the agent design, but these are the type of capabilities that we'll have to build on the platform to support our customers who are building these agents. And what's really good and important is if I take, I think it is this one, which is, okay, that was 69. I want 71. Here we go. This was the agent call which was the one that it was a false positive. And you can see there wasn't even it didn't even iterate over itself. It just had the system prompt, had the user prompt, which was the get diff, which is quite extensive, and it made a judgment. And it made a judgment because it had to infer a load of stuff. The agent wasn't really grounded on anything other than just purely the get diff. But it's great. I can then capture that information. I have everything, the tool calls, the number of times it iterated, to have that introspection. So I have the ability in my evals to take those raw inputs and outputs and grade it as a black box. But then I've also got the ability to hone down and tweak system prompts and things like that. So I can re-execute and those agents independently. Really, really important part of your full SDLC. Okay. So just kind of recap everything that we've got there. So full GitHub, Dark Factory does simple changes, some complex ones it doesn't do now because I'm going to have to start adding the capabilities to my agents, but I'm harvesting all of the information from the beginning. I have an LLM gateway there so that I can switch my models, I can manage my costs, which is really, really important. Evals are the solution to the problem of how to test these systems. You're going to have to build storage for all of your eval data sets. You're going to have your own CI job specifically for running those regression packs, those test packs, for running those eval solutions. Both you're going to have quick ones that are graded so that they can run fast, and then you're going to have ones that are going to be more expensive to run, which will often use things like LLM as a judge to be able to determine good and quality outputs. You're going to want to have that ground truth data set that you build over time. And then you're going to want to have that observability layer that gives you end-to-end telemetry, right? So using either OTel with something like Open Inference, so you can get that really, really heavy introspection into all of the agent runs. And so you can do full diagnosis. So when someone says, hey, this didn't work, or this was a problem, you've got that insights that you can dive into. And these are the capabilities that you'll need to provide as a part of your platform to be able to support that agent testing. What's next for Talos? External storage for that eval data. One of the areas I'm quite interested to exploring is around sandboxing of agents. So right now, these are packaged in Docker containers. They're not necessarily secure if you're running untrusted code. And so one of the things is to look at micro VMs as a strategy for managing more secure runtime environments. Reducing and swapping out different models, so building out and having some concrete examples of swapping out the different models in the agents and seeing those regression packs fail and how they improve, and then enhancing the agent's capabilities over time. So that's me. That's the end of the demo. I'm happy to take some questions. If anybody has any, you can just put them into the chat. Okay, so I've got a question here. How we solve this for multi-repo problem. So I think what we're building here is a capability, and you're going to have a sort of a test solution to test that capability and build your evals. If you're going to deploy these agents into your SDLC and they're going to be servicing multiple repos, you're going to have an explosion of behavior, but the strategies stay the same, right? So whilst I'm running this inside one repo for simplicity from a demo's perspective, that's not how you would do it in production, right? You would have these actually deployed. One of our customers that I've been working with around a PR bot specifically wanted to centralize the PR agent because that's so they can manage it, and all projects will go through that, right? So they host their own build runners, so they can want to manage that on their own infrastructure, cloud infrastructure. So the strategies still apply, capturing all of that data, building up your data sets. But I think what it shows is the complexity of the task to eval these systems. And I think that's quite where we are in the life cycle of understanding and building these is people aren't really appreciating just how much effort and investment has to go in building those eval suites to make sure that your systems don't regress. I also think so. Would you build a centralized repo that controls branched repos, or more? Would you build more of a custom solution? I think what we're starting to see is um, I believe that most of our customers will go down the path of building their own agent capabilities across their SDLC. So Copilot, implementation of Copilot is not an AI strategy. Um, you want to put your own guardrails into here. So like my code review agent here is very, very simple, but you may have your standard coding rules that you want to add into your agent. You may want to do specific tests. You may have a runtime environment that's very specific to the type of workloads that you're doing. You may have particular governance and controls that you also want to put into your agent. So you're going to want to build and design your agents to that are tailored to your environment. Um, And also, you want to manage all of your agents because you want to manage your cost. If you use just all of the third-party agents, you're going to be ending up in quite you've got an agent in Jira, you've got an agent in GitLab, you've got agents in Google doing stuff. Like you're going to have all of these different agents with all of your data going everywhere. And how do you control? How do you know that they're good? How do you know that they're optimized for your workloads and your scenarios? That's the challenge, right? Plus, there are lots of companies you may buy an agent and bring it in, right? There are a number of products out there now that will just do PR reviews or security reviews. So you may just want to buy one of those and bring that in yourself into your stack. So you're going to end up building a custom solution. So integrating Phoenix, quite simple. There's a lot of overhead coding to be able to put all of that logging in and get all of that telemetry in there. So I won't lie, that is quite an overhead to get all of that in. Uh, if you like clean code, it will be quite frustrating. But yeah, it was quite simple to get it integrated. I should say, although I'm using it Rise, not sponsored by them or anything, it's just a product that I've been playing around with. So I quite like this interface, and it has a set of capabilities to capture the telemetry information and package those up into data sets. And you can even test your system prompts and replay them back inside the tool. So it's quite good for playing around and understanding that part of it. It's for your agent tuning. So I'm using Vercel in this particular scenario. So it is, sorry, the question is, do you have agents which provision the test environments and deprovision them? So I'm using Vercel that in this particular scenario. In other scenarios where we're provisioning environments, that is not really, that's a deterministic automation. So you're probably just going to use a standard automation to provision those environments. It won't necessarily be an agent to do that. And I think this is one of the balances that we will have to play, which is we will probably use agents. We're going to end up using agents a lot to build deterministic automations. And so, which is why I use the diagram to show which ones were going to be non-deterministic, where an agent works best in that scenario, like generating release notes, versus where it's just a straight automation that I'm going to use because I don't want to burn my token budget, right? These are concerns that today aren't really hitting us, but as people start to use these tools more and more and more, things like token cost control are going to become really, really important. So very quickly we'll go, actually, I'll use a coding agent to build an automation, and then I'm going to run the automation over and over again. Any other comments or questions? No? Okay. Well, look, thank you everybody for your time. I really appreciate it. the GitHub is there, so anyone can go in and have a look and have a play around with it, fork it, have a play around with it yourself. I think it's a really interesting example to kind of like build these dark factories, right? Because it starts to get us thinking about what are all of the concerns. If you're playing with this in your own time, then you can start to think about how you're going to take that into your work environment and the complexity of your work environment and manage that, right? I think that complexity is going to be a big thing to be challenged. And yeah, if you want to talk about these things, as I said, LinkedIn, Twitter, hit me up. More happy to have a chat. And also Clear Route Hiring. So if you're interested and want to work on projects like that, go to our website. We've got a number of open jobs there as well. So we great to look forward to seeing you. Thank you, everybody. Cheers.